Good afternoon po, Ma'am Elizabeth Castro. Good afternoon din po sa mga teachers po dyan sa New Isabela Central Elementary School, City Schools Division of Tacorong, Sultan Kudarat. Once again, good afternoon everyone. Welcome to the second part of our national work-on for the 21st century researchers and educators with the theme Digitalization and Research in Education, Leveraging the Emerging Trends in Data Management. So I won't take it longer. I will now introduce to you the second speaker of this afternoon's event. But before that, kindly follow, or I remind you again to the etiquette that should be observed during this event. First, always open your camera. Then you have to mute your mic and use your headphones or earphones and find a seat or location that is comfortable and well lighted. You should also wear business or smart casual attire and finish the whole webcon and complete the evaluation for you to get your certificate. And always direct your concern to the personal message on our page or in slido.com provided code or our email address so we can provide answers to your concern. So at this juncture, our guest speaker this afternoon will have a talk on knowing what to use, a comprehensive discussion on parametric and non-parametric tests. He is the member of the Foundation for Upgrading the Standard of Education, which is a private organization that offers trainings to teachers in the Philippines. They aim to upgrade the standard of teaching and the quality of education offered by the teachers, particularly in English, mathematics, and science. He is currently taking up his Doctor of Education major in Educational Management at Tarlac State University and is the subject area of Mathematics and Technology and the Student Activities Coordinator of Don Bosco Technical Institute of Tarlac. Presently, he is connected to Beijing 101 Middle School, Beijing, China. Again, a Master of Education major in Mathematics degree holder. Ladies and gentlemen, let us all welcome Sir Albert M. Dizon. Good afternoon, sir.
Hello po, good afternoon, everyone.
Afternoon.
Thank you so much for that introduction. Sir, can you hear me, sir?
Yes, sir.
Okay, thank you so much. I'm asking now the permission of the organizers to share my screen.
Okay, sir. Noted.
For a while. Hello once again. Good afternoon. A beautiful afternoon to each and to one and all. I hope you're doing great despite of what we are currently experiencing during this pandemic. I hope okay po kayo ngayon. Of course, it's very important for us to be healthy. Do not worry, I'm still in the Philippines because of this restriction. I'm just teaching online at Beijing 101 Middle School. Okay, knowing what to use, a discussion on parametric and non-parametric tests. This will be our topic this afternoon, and I hope you will be able to learn something about me or from me, of course, regarding our topic. Before we proceed to my next slide, may I ask everyone, or can you please type in, what is your specialization? Are you a math teacher? Are you now writing your thesis or dissertation? Are you a statistician or a research teacher? Okay, I'm a social studies teacher. How about the others? Okay, so that I know. Science teacher, research teacher. Okay, good afternoon po. Math teacher. Okay, English and math teacher. Okay, I think we are diverse here. So meaning to say I need to what they call this, really accentuate how are we going to utilize the non-parametric and parametric tests. Of course, specifically when we will be writing our dissertation, also our thesis and masters. Okay? So, uh they say, or the truth is, it is difficult and complex to conduct scientific research or behavioral research. That is very true. If you could offer, or if I could offer one bit of advice on writing a research or writing research rather, it would be to follow a systematic on writing systematic and future oriented process. I've also taught research in senior high school at Don Bosco Technical Institute, Tarlac. And I told my students for them to be futuristic. For them to be futuristic. Why? Because if not, okay, they won't know. For example, they are just focusing on the current uh, priorities that they have right now without even thinking what statistical test do I need to utilize? What particular, what are my variables? What or how can I gather? Or how will I gather my data? And now, you know what? I am already writing my chapters 1 to 3 for my dissertation. And having these two values, having these two principles, which is being systematic and future-oriented process, I believe, well, of course, it's very difficult, but it could lesser the difficulty in writing my dissertation. In other words, you know exactly how you're going to go about doing research. You know what you're trying to get out of whatever topic that you have, and you have a clear picture of where you're starting and where you're going. Of course, it's a question of what will be my problem, correct? What will be the best problem which can be solved given my resources, given my interest, given my passion, given the need, okay, in our existing society or in our existing environment. That is the first thing that you must adhere, and that is basically awareness. Awareness of what is happening in our surrounding. And of course, if you already have the problem, the next question is, what will be my variables? What will be my variables? Because if you can answer that question, you will already have an idea what are your data or what would be the data that you need to be collected. And it doesn't stop there. Yes, you know your data, and what do you call this? What are the specific data that you need to collect? And of course, given those data, what particular statistical test that I need to utilize, correct? Well, I know I've read some of you are not math teachers, you're not statisticians, but I guess, or but I firmly believe you should know what statistical test you should be using. Because sometimes as a researcher, if for example they are not a math teacher, they know that they can actually ask the service of a statistician. They would say, it's not my problem, it's not my problem. I won't be focusing on what statistical test that I need to utilize. No, that's a misconception. All of us as researchers should know what statistical test I need to utilize. And it won't be answered after gathering data. No, before gathering data, or upon thinking or upon deciding what will be your problem or what will be your topic, you should already know what statistical test that you need to utilize. In terms of selecting a statistical test, the most important question is, what is the main study hypothesis? Of course, okay, if you will be utilizing uh, statistical tests, whether parametric or non-parametric, there must be a hypothesis. There must be a null hypothesis, which is your claim to be tested. Of course, if you won't have a hypothesis, what should you test or what will you test? In some cases, there is no hypothesis. The investigator just wants to see what is there. And that is basically exploratory. That is basically a descriptive study. And that is okay. And that is okay. It depends on the nature of your study. It depends on what is the goal of your study. If you want to test something, if you want to verify something, therefore, non-negotiable, you should use a test, a statistical test. For example, in a prevalence study, there is no hypothesis to test. And the size of the study is determined by how accurately the investigator wants to determine the prevalence. If there is no hypothesis, then there is no statistical test. Remember, it is important to decide a priori which hypotheses are confirmatory. That is, are testing some presupposed relationship. And basically, that is your null hypothesis. That is your claim. If you think there's no significant difference or there is no significant relationship between absenteeism and the academic performance of the students, you should test that. You should verify that. Of course, we know there is. Okay, we know there is. For example, our variables are absenteeism and the academic performance of the students. We know there is a significant relationship. But the question is, what is your proof? What is your proof of that claim? And of course, remember, nowadays, it's very important to be data-driven. We are in the academy. Majority of us are parts or are members of a school, of an academic institution. And I know before we decide to something, we should be data-driven, or our decision must be data-driven. And for us to have a solid decision or rational behind our strategies, behind our suggestions, of course, we should be conducting research. And that is, again, the reason why we have, I think, action research memo from the Department of Education. And I hope we embrace, we accept the significance of that particular memo. And at this point, before we proceed to statistical tests, let us identify first the importance of understanding our variables. It's very important to know what are our variables, what are the classifications of our variables. Do we have qualitative, quantitative variables, categorical variables, and so on, so that it would be easier for us to identify what statistical test that we can use. The central purpose of a research is to solve problems and improve the welfare of the society. I hope that is our principle or philosophy, why we are really into research. To improve the welfare of the society, to contribute to the body of knowledge. To research is to search or investigate exhaustively. And yes, we need to maximize our resources, our competence, just to make sure that these two variables, variables presented to us, can be differentiated, can be correlated and all. It is a careful or diligent search, studious inquiry, or examination, especially investigation or experimentation aimed at the discovery and interpretation of facts. Research, remember, this cannot be possible without taking into consideration measurable factors. And these measurable factors are the variables that we have. These are the subjects to change due to circumstances. Anything that can vary in research due to some circumstances are called variable. Same in mathematics. Same in mathematics. We called the literal coefficients or the letters as variables because they are subjects to change. However, based on what has been learned in the current research course, the principal aim of a variable is for us to identify how can they contribute to our decision. Sometimes there are variables that cannot be correlated, but still some researchers insist to know their correlation. And of course, if we cannot prove, if we cannot give supporting documents that there must be or there can be a correlation between the two, I think our claim will always be you're correct, you're wrong. And so at this point, let us try to figure out the different variables that we need to know before starting to determine the correct statistical tool needed to complete our study. First is the relationship between independent variable and dependent variable. We all know that the independent variable is basically a constant variable. A constant variable. This is basically the given variable that we have. And dependent variable will be our outcome. Okay, will be the result of our study. For example, time spent studying causes a change in test scores. And it is not possible that test scores could cause a change in time spent studying. Otherwise, there would be another study. There would be a follow-up study. And that is from the scores, you will be now scheduling, or you will be now forming, okay, a schedule of your review period. Therefore, time spent studying must be the independent variable. This is basically the predictor of what will be the outcome, okay, of your test score. Test score must be the dependent variable because the sentence doesn't make sense the other way around. Unless, just like what I have mentioned, there would be a follow-up study. As defined earlier, a variable is as opposed to a constant is simply anything that can vary and that many researchers consistently looked at the relationship between these two variables. While the variation of independent variable will influence the variation of the dependent variable, both variables give the study a focus. And that is one of the many considerations that we deal in terms of studying variables. It gives you a focus. And you know what? That is the reason why researchers or student researchers can finish their paper because of out of focus, because of numerous variables that they are considering. Dependent variable relies on and can be changed by other components, and these other components are basically independent variables. Another, in research that investigates a potential cause and effect relationship, a confounding variable is an unmeasured third variable that influences both the supposed cause and the supposed effect. Therefore, this is an outer variable that can affect both the predictor, both the predictor and the outcome, both the cause and effect variable. A confounding variable is one you did not account for that can disguise another variable's effects. And of course, they must be significant. They must be significant. Not all variables can be considered as confounding. It is important to consider potential confounding variables and account for them in your research design to ensure your results are valid. Confounding variable are a type of extraneous variable that are related to studies independent and dependent variables. And we will be tackling extraneous variables on the next slides. On the, for example, of confounding variables are the following. For example, you want to determine, okay, the academic performance of the students. You want to determine what are the factors affecting the academic performance of the students. You have mentioned the socioeconomic status. The socioeconomic status. And you have found out that, of course, this is just an example, the lower the income of the parents, okay, the struggling the student would be. Okay, so your independent variable would be the socioeconomic status. Okay, given the income of the parents, also, and the dependent variable will be the academic performance of the students. And you didn't actually consider the confounding variable. And what is that? Based from our definition, this can be, okay, this can affect, okay, the independent and the dependent variable. For example, okay, the what they call this? The sorry for that. The willingness, okay, the willingness of the parents, the willingness of the parents and the willingness of the students to finish their course or their program. Of course, the willingness of the parents and the students could basically affect the independent variable in the sense that they would be, okay, they would be trying their best to maximize the resources that they have just to support their child. And so, also the academic performance of the students. Basically, confounding variables are somewhat correlated with the independent variable. This may be a causal relationship, but it should not be. It must be casually related to the dependent variable. But again, it targets both. For example, again, you collect data on sunburns and ice cream consumption. You find that higher ice cream consumption is associated with the higher probability of sunburn. Does that mean ice cream consumption causes sunburn? Of course not. Here, the confounding variable is basically the temperature. Hot temperatures causes people to both eat more ice cream and spend more time outdoors under the sun, going to beaches. And so, it results in more sunburns. And that is basically confounding variable. And the other one is the composite variables. A composite variable is two or more variables combined to make a more complex variable. For example, the BMI index. The other factors, for example, how would you categorize mental health? How do you categorize job satisfaction? an individual or people, there are a lot of categories that we need to combine in terms of the weighted averages for us to come up with the general job satisfaction of a person. And that is basically composite variables. Next would be for example, next would be the intervening and mediating or moderating variables. Moderating variables or mediating variables change the relationship between dependent and independent variables by strengthening or weakening the intervening variable's effect. Remember, this variable explains the process through which two variables are related, while a moderating variable affects the strength and direction of that relationship. You can think of a mediator as a go-between for two variables. For example, sleep quality, an independent variable, can affect academic achievement, a dependent variable, through the mediator of alertness. Okay? Again, through the mediator of alertness. In a mediation relationship, you can draw a relationship or an arrow from an independent variable to a mediator, and then from the mediator to the dependent variable. For example, sleep quality, if you want to strengthen that, okay, if you want to increase the quality of your sleep, okay, of course there should be an effect. There should be an effect also to the outcome or the dependent variable. Correct? If you deprive yourself, okay, from your sleep, from quality of sleep, of course there will also be an effect to the outcome, to the results. In contrast, a moderator is something that acts upon the relationship between two variables and changes its direction or strength. Okay, it changes direction or strength. This is basically the one difference, okay, between an moderating variable and confounding variable. For example, mental health status may moderate the relationship between sleep quality and academic achievement. The relationship might be stronger for people without diagnosed mental health conditions than for people with them. Correct? So that is basically moderating variable. You know what? I am just discussing this for us to know what are the things that we need to consider before we use the test that we must have, because sometimes these variables are considered before using a certain statistical test, before of course trying to give an analysis, trying to give an interpretation about our study. Next would be the intervening variable. Intervening variable is a variable that affects the relationship between an independent variable and a dependent variable as well, of course. Often, this type of variable can appear when researchers are studying the relationship between two variables and do not realize that another variable is actually intervening the relationship. For example, the level of education and the spending of a person. They say, for example, if you have higher level of education, you spend more. Correct? You spend more. And I think that is not basically true, because it depends again to your income. Correct? It doesn't mean that you have higher level of education, you will have, or you need to spend more. For example, I myself, I'm taking doctorate degree, a doctorate program, but then again, I am not spending much because of my source of income when I am teaching in a school here in the Philippines. Correct? That is basically intervening variables, sometimes called a mediator variable. However, we cannot basically know that the strength, the direction. is a theoretical variable the researcher uses to explain a cause or connection between other study variables. And again, you must consider these, okay, in our study, okay? It gives a flavor. It gives a twist. It gives much competence, okay, with our study and significance. Next would be the control variable. It is anything that is held constant or limited research study. It is a variable that is not of interest to the study's aims, but is controlled because it could influence the outcome. For example, your research question is, does caffeine improve memory recall? Does caffeine improve memory recall? Of course, your control variables would be the participant age. You have to consider the participant age. That is a control variable. You won't answer the question, does caffeine improve memory recall? And then you have a diverse different ages as your respondents or as your participants. Noise in the environment. And another is the type of memory test. Correct? Another, do people with the fear of spiders perceive spider images faster than other people? Of course, the other control, the control variables that we have, computer screen brightness, correct? Room lighting, visual stimuli sizes. So this must be held constant in our study so that, okay, so that we could say that there's a validation or our results would be valid and reliable. On the other hand, an extraneous variable is any variable that you're not investigating that can potentially affect the outcomes of your research study. If left uncontrolled, extraneous variables can lead to inaccurate conclusions about the relationship. For example, does sleep deprivation affect driving ability? What are your extraneous variables? Of course, the road conditions, years of driving experience, and noise. You won't say that, for example, you cannot drive because you deprive yourself from sleep. Of course not. It's because of the road condition. It's because of the years of me driving. Another, is memory capacity related to test performance? Extraneous variables, of course, the test anxiety of the students, of the test takers, test taking time of the day. Are you giving a morning session for your exam or an afternoon session? Again, these are the consideration that we must ponder for us to make sure our results would be what they call this, analyzed, valid, and reliable. Of course, we won't be saying that there are correlation between these two without even thinking of other factors. And again, that is one of the things that you must adhere in writing a research. You must be skeptical, detailed in terms of your decision making, of the things that you are that you need to consider. Other variables are discrete and or continuous variables. Discrete variables, these discrete and continuous are basically under quantitative variables. Discrete, of course, any numerical variables you can realistically count. Number of tables, number of chairs, number of lights, number of laptops, number of students, and all. Continuous variables, on the other hand, these unwanted variables can unintentionally change a study's results or how a researcher interprets those results, depending. I think I didn't change that. These are basically variables which has interval or in fraction form or in decimal form, or there is infinitesimal change, you can actually determine the infinitesimal change between two values, between two given data. Next would be the qualitative variable. In qualitative variable, okay, we have three: binary or dichotomous, the nominal, and the ordinal. Okay, binary, any numerical value. Again, I forgot to change binary or dichotomous. The expectation would be, or the expected answers are two. For example, yes or no, pass or failed. These are examples of binary variables or dichotomous variables. Next would be the nominal variables. They are categorical variables. I think I have the next slide here. Okay, binary nominal variables are categories cannot be ordered or ranked. For example, the religion, marital status, political affiliations. Okay, and of course, the ordinal, if the categories can be ranked or ordered. Educational attainment, socioeconomic status. Okay, so meaning you have to consider the following before, okay, trying to identify your statistical test, because it would be easier for you. Let me tell you that it would be easier for you to identify your statistical test. Another other variables that we need to consider are interval and ratio. Interval, these are variables for which their central characteristic is that they can be measured along a continuum and they have numerical value. Okay, they have numerical value. Also, for ratio, these are interval variables, but with added condition that zero of the measurement indicates that there is none of that variable. For example, of interval, temperature, test scores of the students, it doesn't mean that you obtain zero. There is no significant interpretation. On the other hand, ratio, meaning to say weight, volume, kilometers, okay, distance rather, and all. Okay, so this time let's proceed to descriptive statistics and inferential statistics. Okay, descriptive and inferential statistics. My question would be, are you just explaining the situation that you currently have? Are you just what they call this, trying to assume? Are you trying to assume? Are you trying to give probabilities? If yes, okay, I think we need to consider the two. Descriptive statistics, in a nutshell, intend to describe, okay, a big chunk of data with summary charts and tables, but do not attempt to draw conclusions. Basically, we are just using the measures of central tendencies, the measures of variability, such as variance and standard deviation. If you are just using those measurements, okay, I think we are just what they call this, using descriptive statistics. But if you want to use these values, if you want to use these values to assume, to predict, to give what they call this, an outcome, what will happen given these values, I think, okay, we are basically using inferential statistics. From the term itself, we are making inferences. We are making inferences. Now, you ask yourself, am I trying to predict relationship? Am I trying to predict differences? Or I just want to give a date. I just want to give a numerical value to my school, to my audience, to my readers and all. Okay? And another, for a while, another, if you want to use inferential statistics, you have to identify these two. Okay? You have to answer these two rather. Number one is the purpose. The purpose of your study. Is there a significant difference? Are you comparing? Do you want to know? Do you want to know which is the best strategies? Who is better? Do you want to know the best way to resolve this issue, to address this problem that you are encountering? Or are you just trying to determine the significant relationship? Do you want to know that if for example, you increase this particular value, there will be changes to your another variable? You have to answer this before, again, okay, trying to think or ponder what particular tests should I need to use. Next would be the type of data. Do you have qualitative characteristics? Do you have qualitative characteristics or quantitative, both in nature and property? Are you, or do you have, or did you collect, or did you gather data which are perceptions, which are nominal in nature, which are categories? For example, the educational attainment and all, the religion, the gender, the job satisfaction and all. Quantitative, if for example, you're using scores, frequencies, you have to address this. Remember, there are times that given a categorical variable, in using SPSS, you will be you will be representing those numerically. Okay, so that is still considered, okay, qualitative, even though you have used numerical data or numbers to represent those ideas. Okay, so these two must be addressed. Why? Because after sorry after identifying your answers with those two questions or with those two big ideas, we can now identify whether we will be using statistical tests, which are included in chi-squared family, t-test or ANOVA family, or correlation family. Okay, so we have three common families that we considered in terms of statistical tests. We have chi-squared, we have t-test or ANOVA family, and correlation family. Okay, so just like what I have mentioned, we have to address the purpose and the type of data before we identify the family of statistical tests that we need to utilize, or where will our statistical tests be coming from. Okay, if for example, your purpose is comparison, you need to compare, and your data are categorical, okay, your statistical tests will be coming from chi-squared family. Okay, again, if your purpose is to compare, okay, and then your type of data is categorical, therefore you will be searching for chi-squared family statistical test. Now, if your purpose again is comparison, okay, to compare data, and then your type of data are categorical and continuous, or both continuous, okay, you will be using t-test. I repeat, you will be using t-test family test. Okay, I repeat, if your purpose is comparison, and then your type of data are categorical and continuous, or both continuous, you will be using t-test or ANOVA family. Okay, next, if your purpose is to determine a relationship, again, if your purpose is to determine relationship and your data are continuous, okay, both continuous, therefore you will be using correlation family test, or your statistical test will be coming from correlation family. Okay, so I hope that's clear. Now, again, we have this three statistical tests, our family. So we have chi-squared family, t-test, ANOVA family, and correlation family. Okay, now, of course, there are a lot of options. Okay, there are a lot of options that you need to consider. Okay, before what they call this? Before of course, for example, you're done identifying, okay, I'll be using statistical tests under t-test or ANOVA. But it doesn't stop there. There are a lot of options still that you need to consider. And that is why we need to, again, we need to discuss or study about parametric and non-parametric tests. You know what? It's very easy. First, it's very easy to consider what particular test that you will be utilizing, either parametric or non-parametric. In parametric tests, you will be using the raw scores. Okay, you will be using whatever raw scores that you get or that you gathered. And then for non-parametric tests, you will be what they call this, ranking. Okay, getting the order, the arrangement of the raw scores that you have. You must represent these raw scores into ranks. Why? Why do we need to do that? For example, in parametric, we have group A, group B. The raw scores are 5, 8, 12, 15, 12, 25, 38, 52, 100, 120. What do you notice in non-parametric? We rank them. And what do you notice now? In group in your left, okay, in the left part of the screen, you can tell, okay, the difference between the raw scores, correct, between group A and group B, which group has higher scores, correct, and to what particular what they call this, to what particular level, to what particular interval, to what particular difference that you have, or you have, unlike in non-parametric test. You cannot vividly see, okay, the difference because of the rank. Okay, why? Because in parametric test, okay, in parametric test, the values that you have can, okay, can describe the population, can use or can be used to assume something about the population. Unlike in non-parametric, we cannot use what we have to assume something about our population. Therefore, there must be specific tests that we should be utilizing. Question: does your data allow for a parametric test, or do you have to use a non-parametric test like chi-square? The rule of thumb would be, for nominal scales or ordinal scales, use non-parametric tests. I repeat that. For nominal scales or ordinal scales, use non-parametric statistics or tests. For interval scales or ratio scales, use parametric statistics. As you have noticed, nominal or ordinal are basically qualitative data, and interval ratio are quantitative data. Correct? Parametric and non-parametric are both are utilizing random independent samples. Of course, okay, of course. Our samples must represent, okay, our population. However, it depends on the number of data that we have. For example, if you have lesser number of respondents, lesser number of samples, sometimes researchers or statisticians use non-parametric tests. Why? Because again, the data that we have, the information that we have cannot sufficiently give assumption about our population. Unlike using parametric tests, we need, okay, we need numerous values or numerous samples. And of course, it is tantamount to saying, okay, the higher the number of data, the respondents that we have, the reliable the data, the interpretation that we will have. Of course, 10 versus 100, 30 versus 150. Of course, again, they must be representing, even though they do not have the same number of respondents, they must be the best representatives, okay, of our population. Actually, that is the first consideration that we must follow. They are the best representative of our population. Also, other reasons to run non-parametric tests. First, one or more assumptions of a parametric test have been violated. Later on, we will be discussing the normality and the linearity, and these homogeneity rather. These are the two tests that we should be doing before deciding, okay, that will be using statistical parametric statistical test. Your sample size is too small to run a parametric test. Okay, remember the common the number that we must follow, or the standard number, is our n must be greater than 30. Okay, must be equal or greater than 30. That is our standard for us to utilize a parametric test. Your data has outliers that cannot be removed. Okay, your data has outliers that cannot be removed. You know what? That is one of the advantages of non-parametric tests. Since we are what they call this, ranking our values, okay, we are assigning numbers, we are assigning ranks to our raw scores, okay, we avoid what they call this, we avoid eradicating, or we avoid removing a value or removing the outliers. Okay, unlike in parametric tests, if for example we found an outlier, we immediately remove that, because we know it will affect, okay, somehow, or maybe it will bring a great change or difference to your final interpretation or analysis. Again, that is basically one of the advantages of uh what they call this, non-parametric tests. Your data has outliers that cannot be removed. Again, you want to test for the median rather than the mean. And since we are basically using medians, by the way, in parametric tests, we are using means. In non-parametric tests, we are using medians. Okay? Most of the time. Okay? Most of the time. And so, uh, we use our medians, okay, to give interpretation, to analyze, and these are the values that we insert to our formula, to our computation. Okay, parametric tests are more powerful. Again, we go back to the idea that, remember, we use interval and ratio scales using parametric statistics, or quantitative data. And remember, interval, or part of parametric tests are continuous variable. And we consider we consider infinitesimal change or infinitesimal interval in continuous. Therefore, it gives us a vivid computation, a vivid value, a competent value, a strong value to give interpretations or to give analysis about our population. Okay? Uh, Less likely than non-parametric to make a type 2 error. Okay? Less likely than non-parametric to make a type 2 error. Since it is powerful, remember, type 2 error is basically rejecting false null hypothesis. Okay? Rejecting we reject uh false what they call this, interpretation or analysis. Okay, so meaning to say, using parametric tests, we avoid that. We less likely make these type 2 error. And of course, non-parametric, less statistical power, again because of the assumptions that we have. Okay, because of the assumptions, because of the median, because we are not using the raw scores. Okay, there are several tests that can be used to assess whether data are likely from a normal distribution. The most popular are the Kolmogorov-Smirnov test, the Anderson-Darling test, and the Shapiro-Wilk test. Okay? This time, of course, we have, it doesn't mean that, okay, I'll be using parametric tests because of what Sir Albert had mentioned regarding the assumptions and all. Okay, it doesn't stop there. We need to prove that we are allowed, or it's best for us to use statistical tests. Okay, and we need to pass the test of normality and the test of homogeneity. Test of normality, we have three: the Shapiro-Wilk test, the Kolmogorov-Smirnov test, and the Anderson-Darling test. Okay, each test is essentially a goodness of fit test and compares observed data to quantiles of the normal distribution. The null hypothesis for each test is the data follow a normal distribution versus the alternative hypothesis, which is data do not follow a normal distribution. If the test statistically significant, which is the p value is less than 0.05, then the data do not allow or do not follow a normal distribution. And a non-parametric test is warranted. Therefore, in this test for normality, we are still using the p-value. And remember, p-value is what we need to compare to our level of significance, or to our alpha, or to the maximum error that we have in deciding whether to reject or to accept our null hypothesis. Okay? It should be noted that this test for normality can be subject to low power. Okay, but however, as a researcher and as a statistician, I would be suggesting for you to use what they call this Shapiro-Wilk test. Actually, they have the same. They have the same answer. They will have the same answer rather. But again, Shapiro-Wilk test is more specific. It gives you more specific. Sometimes, for example, you cannot decide whether to accept or to rate this as moderate or to rate this as low. Okay, because of the tie, because of the values, because of a closer value. So Shapiro-Wilk test will break that tie, will break the interval. Okay, it will give you more specific interpretations or values rather than the Kolmogorov-Smirnov test. But again, they will be having the same answer. Okay, it seems that you can assure yourself using Shapiro-Wilk test. And another would be the test of homogeneity. Okay, the test of homogeneity. You have to utilize Levene's test. It is used to assess the equality of variances for a variable. Remember, okay, in parametric test, most of the time, we must have equal variances. Okay, we must have equal variances. Of course, the purpose of variances is for us to determine they have the same reliability and or consistency. Okay, of course, remember, the lower the reliability, the lower the variance that we have there, the standard deviation, the consistent the scores are. Okay, the more reliable the data would be. Meaning to say, we lessen the scatteredness, the dispersion of our data. Okay. Also, it's very important for us to determine equality of variances in using parametric tests, because sometimes, yes, it has lower mean, but then again, it has a higher standard deviation compared to the other group, and it would change, okay, your interpretation. It would change your interpretation for that. Okay. Also, equality of variances would give you an idea whether you will be utilizing directional or non-directional tests. Remember, non-directional tests means you know that there is no significant difference. You know that there is no significant relationship, or should I say, your mean is not equal, your population mean is not equal to to the sample mean. Okay, your mean 1 is not equal to mean 2. That is non-directional. Okay. However, if for example you have an equal means and of course an equal variances, okay, you cannot determine, okay, if you will be using one directional test, whether a negative directional or a positive directional. Okay, if you will be using uh in your alternative hypothesis, for example, the mean is larger than the second mean, the sample mean 1 is larger than the sample mean 2, the population mean is lesser than the sample mean that you obtain, acquire, and so for and so on. Okay. So meaning to say, it's very important for us to use this test, the Levin's test, for us to assess the equality of the variances for a variable. Because sometimes, again, some statistical tests or parametrics test need to have equal variances, need that our group must have equal variances. Okay, and other things. Okay, non-parametric tests are valid for both normally distributed data and normally distributed data. So why not use them all of the time? Okay, this is basically one of the questions I have encountered. Okay, and the answer would for this would be first, we are really interested in a significance test alone. Okay, we would like to say something about the population from which the samples came. Okay, so we are not just saying, okay, there is a significant relationship between the two variables, period. Sometimes we do that. Sometimes we do that. We say that there is a significant relationship between the two variables. Because we are not using raw scores in non-parametric, we cannot give the infinitesimal difference or relationship between the two variables that you have. Unlike in parametric tests, it can give that assessment. It can give that quantification. Okay. Second, it is difficult to do flexible modeling with non-parametric tests. For example, allowing for confounding variables using multiple regression. Okay. Next, parametric tests usually have more statistical power than their non-parametric equivalents because you know what? In every parametric test, I'll be giving the counter non-parametric test for this. Okay, so that we sometimes we know that we are comparing paired samples, and then since we want to test the difference between a paired of paired samples, we decide that we use t-test paired samples or t-test for paired samples. However, sometimes because of our data, because of the gathered data that we have, there must be a non-parametric test that we need to utilize. Same goal, same objective. Okay. Reasons to use non-parametrics. Okay, first, underlying data do not meet the assumptions about the population sample. I have mentioned that already. Okay. Generally, the application of parametric tests requires various assumptions to be satisfied. For example, the data follows a normal distribution and the population when normality test, and the population variance is homogeneous. However, some data samples may have showed skewed distributions. And that is basically one of the reasons also that sometimes we need to illustrate our data using histogram because we can see the skewness, okay? The degree of skewness of our data, okay? And it can be proven using the normality test that I have provided a while back. The population sample size is too small. The sample size is an important assumption in selecting the appropriate statistical method. If a sample size is reasonably large, the applicable parametric test can be used. However, if a sample size is too small, it is possible that you may not be able to validate the distribution of the data. Thus, the application of non-parametric tests is the only suitable option. And the last one will be the analyzed data is ordinary or nominal. I have mentioned this already. Unlike parametric tests that can work only with continuous data such as continuous data, which can provide infinitesimal interval, non-parametric tests can be applied to other data types, such as ordinal or nominal data. For such types of variables, the non-parametric tests are the only appropriate solution. Okay, this is what I am talking about regarding skewness. Okay, sometimes we can illustrate a histogram. We can draw a histogram for us to determine the normality of our data. Okay, let's proceed now to our parametric test. Okay, first is the one sample test. For one sample test, sample mean compared to a population mean and population variance is not given. Sometimes this particular test is used if we are conducting industrial researches. Okay, why? Because in industrial researches, the population mean is what they call this is observed. Okay, what do I mean? Can be observed, can be found. Okay, can be one of our given quantities. Okay, so meaning to say, this one sample t-test, we have to compare the sample mean that we have from the population mean, given the population variance is not given. Okay, sometimes population variance is given. Okay, and the counterpart of this one sample t-test, okay, is the one sign t-test. One sample sign or one sign t-test. Okay, again, we use median for that. Okay, next would be the t-test for independent samples, used to compare the means of two independent groups. Okay, we used to compare the means of two independent groups. For example, we want to determine the significant difference between the scores of section A and the scores of section B. Okay, if we have two independent groups and then we want to compare their scores, okay, their raw scores, we use the t-test for independent samples. Okay, and the counter non-parametric test for this is the Whitney U Test. Okay, the Whitney U Test. As you can see, okay, all I have to do is to rank the values that I have. Okay, that I need to rank, okay, the values. Okay, I think I forgot to rank this. For example, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. You need to rank the values. Okay, also, the Whitney test used this test to compare differences between two independent groups when dependent variables are either ordinal or continuous. For example, the effectiveness of advertising for two rival products, brand X and brand Y, was compared. How many independent groups that you have? Two, brand X and brand Y. Market research at the local shopping center was carried out, with the participants being shown adverts for two rival brands of coffee, which they then rated on the overall likelihood of them buying the product out of 10, with 10 being definitely going to buy the product. Half of the participants gave ratings for one of the products. The other half gave ratings for the other product. See, we have ordinal variable, which is, of course, the overall likelihood of the customers to buy the coffee products. And if we have such, we still compare brand X and brand Y. However, we use ordinal variable. Okay, we use ordinal data rather. Therefore, that would be the time that we need to use the Whitney U test. Okay, next, t-test for paired sample. Okay, t-test for paired sample, still we are comparing values. We are comparing data. However, this data would come from one group or the same group. Okay, unlike an independent t-test. Okay, for example, we have used to compare the means of two paired groups. So we have student 1, student 2, student 3, student 4, student 5. We have the same students, we have the same group, and then we need to get their scores, for example, in math and science, and we need to compare their scores in math and science. Okay, also in paired sample, the reason why it is called paired sample, because there should be no mismatching of the scores or mispairing of the scores. Okay, you cannot pair 92 to 98. You cannot rearrange the scores in math. You cannot rearrange the scores in science. Okay, it should be 92 to 88, 82, and 98, 97, and 99. Okay, for us to, of course, to avoid the what they call this, the inaccuracy when it comes to our computation. Okay, so the counterpart, sorry, the counterpart for the state test for paired sample, if you have ordinal or nominal data, okay, if you use median as your score in interpreting or analysis, okay, we use the Wilcoxon sign ranked test. The Wilcoxon sign ranked test. With this test, you also estimate the population median and compare it to a reference target value. However, the test assumes your data comes from a symmetric distribution. Okay? Symmetric distribution. Okay? Can you still follow? If, for example, you want to compare the means of two paired groups, okay, and then you have ranked them, you have used ordinal data, therefore your test would be Wilcoxon sign rank test. Next, for example, a total of 8 children with autism enroll in the study, and the amount of time that each child is engaged in repetitive behavior during 3-hour observation periods are measured both before treatment and then again after taking the new medication for a period of 1 week. Okay, as you can see, we have the same samples, or we have the same participants who are the 8 children with autism. Okay. Also, we want to determine the amount of time that each child is engaged in repetitive behavior during 3-hour observation periods. Okay, so we have to determine the extent of such behavior. The extent of such behavior, therefore, we will be using ordinal data. Next, analysis of variance. Okay, we're done with 2 groups. Okay, this time we proceed to 2 or more independent groups, or usually 3 or more independent groups. Okay, if we have these groups, we'll be using the analysis of variance. So we have, for example, section A, section B, and section C. Okay, and then if you want to determine, remember, in analysis of variance, it won't give you significant difference between section A and section B and section C. It will give you the general difference among the 3. Okay, the difference among section A, section B, and section C. However, if you want to determine the significance, yes, you have used analysis of variance. Okay, if you want to determine now the difference between section A and section B, you can use the t-test, t-test for independent samples, or the chef's test. Okay, you can use t-test or the chef's test. Okay, and the counterpart for this is the Kruskal-Wallis Test. Okay, the Kruskal-Wallis Test. It is used to compare the means of 2 or more independent groups. Again, of course, using median, or we will be ranking our medians. Kruskal-Wallis Test is used instead of one-way ANOVA to find out if 2 or more medians, again, are different. Ranks of the data points are used for the calculations rather than the data points themselves. Okay? Rather than using the scores, we use high, average, and low. Okay? We have upper, lower, and middle. So we are using those for us to determine the difference. Okay? Next would be, for example, you want to find out how test anxiety affects actual test scores. The independent variable test anxiety has 3 levels: no anxiety, low, medium anxiety, and high anxiety. The dependent variable is the exam score rated from 0 to 100%. Okay? So we have ordinal. We are comparing the ordinal data that we have, of course, which is basically the independent variable. Test anxiety, no, the three which are no anxiety, low, medium anxiety, and high anxiety. And then we are given the dependent variable, which are scores. Okay. Next, you want to find out how socioeconomic status affects attitude towards sales tax increases. Your independent variable is socioeconomic status. So with 3 levels: working class, middle class, and wealthy. The dependent variable is measured on a 5-point Likert scale from strongly agree to strongly disagree. So meaning to say, class, meaning to say, given our categories, or given our groups, the socioeconomic status, okay, our data that we are comparing are ordinal. Okay, that is the reason why we use the median. And the counter, of course, next would be the repeated measures ANOVA. This time, it is basically two-way ANOVA. This is called the two-way ANOVA. Okay? Used to compare the means of 2 or more paired groups. Okay? So same with, this is basically the counterpart of the t-test for paired sample. It's just that we have additional groups. Okay? So we have student 1, student 2, student 3, 4, and 5, and then there's courses. The math, science, English. Okay, courses, and of course there's scores. If we are what they call this, if we are considering two values, categories, the student themselves and also the courses, we will be using the repeated measures ANOVA. Okay, the repeated measures ANOVA. Now the counterpart for this is the Friedman's ANOVA. Okay, the Friedman's ANOVA. Okay, this time what are we going to do would be ranking them. Okay, we will be ranking them. This test is used to test for difference between groups with ordinal dependent variables. It can also be used for continuous data if the one-way ANOVA with repeated measures is inappropriate. Example, some assumptions has been violated. See, our tests are flexible. Our tests are flexible. That is the reason why sometimes my statements are incomplete. Okay, my statements are beyond what is being discussed in a particular article or said by a particular researcher or statisticians. It depends on really, really, really giving details, giving specifications, and reading a lot. Okay, reading a lot. Okay. So example, 9 experts rated 4 brands of Colombian coffee in a taste testing experiment. A rating on a 7-point scale is given for each of the following 4 characteristics: taste, aroma, richness, and acidity. The following table displays the summated ratings accumulated over all 4 characteristics. Okay, so as you can see, we have the experts and we also have the brand, okay, of the Colombian coffee. Okay. Next would be the analysis of covariance. Okay, analysis of covariance. This time, in analysis of covariance, used to compare the means of 2 or more independent groups which cannot be tested by ANOVA because the variable are affected by covariate. Okay, you cannot compare the 2 groups because there is a particular covariate, or there is a particular process used, okay, for this. For example, section A, we have the scores 92, 82, 97, 94, and 88. For section B, we have 92, 82, 97, 94, 88. We cannot, sometimes we cannot use the t-test for t-test for independent groups because, okay, there is there is an initial process, okay, used, which is basically, for example, the pre-test or the pre-discussion about the topic. Okay, therefore, we must consider this scores. Their scores for us to really have a complete, an accurate, and reliable analysis. Okay? Next would be the chi-square test of independence. The one sample test of independence is different from the test of homogeneity. Okay, the sample used in this test consists of members randomly drawn from the same population. Also, this test is used to look into whether measures taken on two criterion variables are either independent or associated with one in a given population. Okay, remember our pattern a while back. Okay, if our purpose is comparison and our type of data is quality categories or qualitative, that would be the time that we use chi-square. Okay, in our previous examples, as you can see, our the combination are ordinal and sometimes continuous. Okay, or quantitative. Okay, this time in chi-square test of independence, we have both both data that we have are categories. Okay, are categories. For example, the level you want to compare. Uh, for example, I have this. Okay, for example, you want to compare the voting preferences of the male and female in terms of choosing or voting for Republican, Democrats, or Independent. Okay? We want to compare the socioeconomic status, the literacy of the voters in terms of choosing uh, the administration versus the opposition. Okay? So basically, that is chi-square test of independence. Okay, we will be using the chi-square test of independence again, we are basically using just like uh okay, the one sample test of independence is different. The sample used in this test consists of members randomly drawn from the population. Also, this test is used to look into whether measures taken on two criterion variables are either independent. For example, the voting, okay, the voting preferences and also the gender are extremely independent to each other. Okay, another example, 90 individuals, males and females, were given a test in psychomotor skills and their scores were classified into high and low using the chi-square test of independent at 0.05 level of significance. The table is shown as follow. Again, two independent variables that we have, which are the sex and the score, of course. And then as you can see, they are both categories. Okay, they are both categorical data. Okay, next would be the Pearson's product moment correlation coefficient. Okay, uh, we have two types of correlational tests, which are the Pearson products and also the regression. Okay, in Pearson's product moment correlation coefficient, it is used to measure the strength of the relationship of two continuous variables. Again, we have two continuous variables and the value that we can give is the value that we need to obtain is the Pearson correlation coefficient or the rho. And given this rho, okay, we can identify if we have positive and negative relationship. And of course, there is basically a scale for that. Okay, this is a misconception of most of the students. If, for example, they obtain a positive rho or Pearson correlation coefficient, they mentioned that they gave rather there is a significant relationship. Okay, they accept the null hypothesis. However, if they obtain a negative rho or negative Pearson correlation, they would say there is no relationship, and that is basically wrong. That is absolutely wrong. Okay, whether it's positive or negative, okay, the answer would be there is a significant relationship. It depends on the relativity, okay, by following our scale of table for raw. Okay, sometimes it's what they call this, most of the time we don't get no significant relationship. We don't get no significant relationship for or zero. Okay, or zero as our raw. Why? Because we proved in our chapter 2 or in related literature, related studies, that the variables that you are using are basically relative to each other. Okay, we are just knowing to what extent, okay, the intensity of their relationship. Okay, for example, the anxiety scores and the work hours. Okay, since, as you can see, we use two continuous variables, which are the scores of the respondents, also the work hours. Okay, we don't categorize them. We don't rank the scores. We don't rank the number of work hours. Okay, linear regression, it used to determine the relationship of two variables. It is also used to predict values of the other variable. It is basically used in economics. Okay? It is basically used in economics and also in math, correct? In linear regression, if, for example, we know the slope already, the purpose of slope is for us to determine the next point. Okay? The next points. Therefore, we can see the pattern. Okay, we can see the pattern using the slope, using aligning those points, connecting those points. We can see the pattern, and so that is linear regression. Using the relationship that we have for two variables, we can also already determine the values, because it can give a certain value in terms of a certain value for us to predict. Okay, to predict what will be the outcome of such study. One variable is considered to be an explanatory variable, and the other is considered to be dependent variable. And that value that I am referring to is the coefficient of determination. If you obtain the coefficient of determination, it explains the extent to which the independent variable x influences y, or the extent to which y depends on x. Unlike in Pearson R, we are just saying there is a positive, there is a high positive, there is a low positive. Unlike in linear regression, it can give you the coefficient of determination. Okay? And we have the simple and multiple regression. Okay, from the term itself, for example, in simple regression, we only have one dependent variable one dependent variable predicted from one independent variable. Okay? So one regression coefficient and proportion of variation in dependent variable y predictable from x. Unlike in multiple, we have one dependent variable and then we have from a set of independent variables. Okay, we can have numerous factors for us to have that particular result. For example, in single predictor linear regression, we have x, okay, predicts y, or y is the result of x. Unlike in multiple region regression, okay, we have multiple predictors. We have x sub 1, x sub 2, x sub 3, x sub 4, and x sub y for us to determine the results for y. Okay, and that is basically the difference between linear and multiple regressions. And as you can see, correlation and linear regression, the purpose is description, inferential statistics. However, in linear regression, we predict, we design experiments. Okay, variables paired because we only have one independent and one dependent. Unlike in linear regression, we have 2, 3, or more values. Okay, I'll stop sharing this one because I'll be showing. Okay. I have utilized this, or I have constructed these. Okay, for regression tests, we have simple, multiple regression, and logistics. So we have the predictor variable, outcome variable, research question example. Okay, I'll be providing this to our organizers so that you can utilize this also for comparison tests. You can use this table in identifying what particular test that you need to use. Okay, that you need to use since it's 4:30. So that we can also have our question and answer portion. Okay, so I think that ends my presentation. Thank you so much for listening, for bearing with my long discussion. Thank you.
Thank you so much, sir, for that wonderful discussion. May I request everyone, if you have some questions, you can write here on our chat box or message at slido.com. Sir, we have one question from Jeffrey O. Ballesteros. Is it possible to test first the data to conclude that the test to be used will be parametric per set checking its test of normality and test of homogeneity?
Is it possible to test first the data to conclude the test to be used will be parametric per se? I think we have to test first we have to utilize first the test of normality and the test of homogeneity for us to be able to determine if we are still or we are allowed to use the parametric test. Well, yes, given our uh, considerations, for example, they are both continuous. We followed the assumptions. We have equal variances and all. But then again, it is still a must for us to test the normality and test the homogeneity of our data. Okay, before finally deciding, yes, I need to use parametric test.
Okay. Sir, can I ask a question?
Yes, sir.
Sir, is sampling can affect your type of test will be used, or if I'm using a convenience sampling, would it be a non-parametric or parametric test?
Okay, actually, that's a very good question. I would say yes. Okay, I would say it would affect your type of test that that you will utilize. Remember, I have mentioned a while back. If, for example, you have a lesser value, okay, a lesser number of sample size, you will be using non-parametric tests. But you know what? I think the question now is, for example, you have used what they call this. You have used a convenient sampling, which is a non-probability sampling technique. The question now is, are you going to utilize a statistical test? Are you going to utilize a statistical test, or are you just going to use a qualitative test or a qualitative research design? I think that is also a consideration. Not only the test that you will be using, but also what type of research design that you need to use. Sometimes, if we have non-probability sampling, if we use non-probability sampling technique, we are not allowed to use either non-parametric or parametric test. Again, it depends on the purpose that you have.
Okay, sir, it means that Slovin formula can be applied both para or non-para.
Sorry, sir, sorry.
Do you think the Slovin's formula could be applicable in both para and non-para tests?
I would say yes sometimes, and I would say no sometimes. And you know what? There are sampling formula that we can use. We have Cronbach. We have also the Slovin's formula. You know what? Sometimes we are not. Sometimes researchers or statisticians encourage you to use Slovin's formula because of the 95% confidence level, and they think that that is too what they call this. You will have too large number of samples. So sometimes we use Cronbach. So meaning to say, the answer for your question, sir, sometimes yes, you can use both. You can use Slovin's formula for both parametric and non-parametric tests. But again, okay, thinking of considering our discussion a while back. Okay, if for example we have lesser values or sample size, I think that is for example lesser than 30. Okay, so I think it's okay not to use the Slovin's formula and for non-parametric tests.
Okay, sir, we have questions here from Marvin S. Dagopulo. Good afternoon. I have read articles with question, is there a relationship, and is there a significant relationship? One question has significant, the other none. Can you explain the difference of the two when we will use the term significant?
Thank you so much. You know what? Since college, I always since college, master's degree, and in my action researches, I always use significant relationship, significant differences. As for me, I do not know if my answer would be correct. Okay, as for me, there is no difference between the statement there a significant relationship and is there a relationship. I think they give the same understanding, they give the same notion. I hope that is correct. That is from my end.
Okay. So, sir, we have also another question from Ma'am Estrella Onatin. Good afternoon, sir. May I ask if what kind of t-test can I use if my research question is there a significant difference in the reading level of grade 1 pupils before and after using digitalized reading materials?
Okay. So first, we go back to our pattern a while back. Okay, what's the purpose of your study? What's the purpose of your study? The purpose is to compare, correct? Compare. And then what will be your type of data? I think the scores. Am I correct? Difference the grading level. I think the scores, okay, of in a reading test of the grade 1 pupils. So basically, we are under T-test or ANOVA family, correct? T-test or ANOVA family. Now, the question is, what type of T-test can you utilize? Since we have the before and after, okay, before and after using digitalized reading materials, you can use first, okay, the paired samples, okay? The paired samples, because you already have you have the same group, the grade 1 pupils, and then you have the scores for pre-test and you have the score for post-test. Okay, I think that is the best t-test that you can utilize, t-test for paired samples.
Okay,
Usually
sir.
paired samples can be used for pre-test and post-test scores.
Yes. Thank you, sir. Sir, another question. Um, Sir, you mentioned coefficient of determination. I am currently conducting a study using regression. What value of coefficient of determination would be acceptable if I want to proceed with regression modeling?
Okay, of course, there will always be what they call this, a table that we can follow. Okay, for that. Remember, uh, in a raw, we are using what they call this, the table for raw, if for us to determine the what they call this, the if we have high positive relationship, high negative relationship, okay. In R squared would be acceptable if I want to proceed with regression modeling. You can basically use, okay, the value. If, for example, if it is positive, therefore, you can proceed that. Meaning to say, it really have what they call this, a good pattern. Okay, a good pattern, an increasing value. Unlike if, for example, if it is negative, remember, if it is a negative, it would be it it decreasing. It won't be what they call this. I'm so sorry for that. Okay, if we have a positive r squared, that's good. Okay, that's good because the value is increasing. Therefore, the slope would be, or the line would be going upward from the left. And if it is negative, it goes downward from the left to the right. So if, for example, our value of r squared is close to 0, if it is close to 0, meaning to say we will have, it would lead to what they call this non-linear value or non-linear value. And another suggestion that I would want you to do, Mr. Marvin, is for you to graph the data that you have. The data that you have, because in using illustrations, you can determine the linearity of your data, and you would say that there is a positive or there is a no negative relationship between the two variables that you have.
Okay, Sir Marvin, you are recognized.
Sir, just a follow-up question. Good afternoon.
Yes,
Just a
sir. Hello
follow-up
po.
question, sir, because coefficient of determination is the square of R. So there should be no positive or negative. Even if I'm going to plot the graph, I think it will have no sense because the positive and negative direction would have no bearing when you square the value of R.
Okay. Hello, sir. Okay. Thank you. Thank you for that, sir. So, okay. So actually, that is a possibility. Okay, that is a possibility. But I would, of course, relate also my answer with the value for raw. However, that is correct. So that is I'm so sorry. I'm checking my notes for that question. So may we proceed to the next question before
Okay. So we have here another question from Sir Jeffrey O. Ballesteros. How about the effect size, sir? Can you explain further po when to validate the data in terms of its effect size?
Sorry. How about the effect size, sir? Can you
Yes
explain
po.
further po when to validate the data in terms of its effect size? So, which particular effect size that you are referring to, Sir Jeffrey? Are you referring to the p-value? Are you referring to terms of its effect size? How about the effect size? Can you explain further what to validate the data in terms of its effect size? Are you referring to the value obtained, the computed value that you obtain after using the statistical test? Yes, sir. Okay. So,
I
you know
think,
what?
sir, he is referring to Cohen's D value.
Sorry, the
Sir
coefficient
Marvin,
of determination.
recognize. Hello, Sir Marvin. Can you repeat the question,
Hello,
sir?
hello, sir. Because one is asking for what is that value?
Okay.
If effect
Mm,
size, siguro yung Cohen.
Points the value.
okay. So, remember, I have mentioned a while back that we are using the coefficient determination for us to determine, okay, the for example, the prediction to what where our relationship goes in terms of using the linearity. But you know what? This measure is represented also as a value between 0 and 1.0. That is why you have mentioned, Sir Marvin, that is correct, that we only have positive values for coefficient determination. So where a value of a 1.0 indicates a perfect fit, meaning to say the closer the value, the closer the coefficient determination we obtain, okay, meaning to say the perfect fit or the perfect relationship that we have, okay. Thus it will have a high reliability when it comes to modeling our relationship, so for future forecasts. While a value of 0, the closer the coefficient determination that we have for 0, it would indicate that the model fails to accurately model the data that we have. So basically, that is how we use coefficient determination. Again, the values is from 0 to positive 1. Okay? The closer the coefficient value for 1, meaning to say the better the fit that we have, the fit that we have, the high reliability that we have to model or to forecast the relationship. However, the lower the value or the closer the value that we have going to 0, okay, meaning to say it would fail, okay, it will give a failing illustration or modeling for us to predict, okay, our relationship.
Okay. Some more questions? I hope, Sir Marvin, you are now enlightened, sir. Is there more some questions? Okay. So it seems that Sir Alberto Dizon, all the participants are now has a knowledge with regards to the parametric and non-parametric test. So at this juncture, may I present to you a certificate of recognition. The certificate reads, PICE I-21 awards this certificate of recognition to Alberto M. Dizon, MAED, for imparting his invaluable time, resources, and expertise as the resource speaker on the topic, Knowing What to Use, a comprehensive discussion on parametric and non-parametric tests. During the conduct of the National Work-On for the 21st Century Researchers and Educators with the theme Digitalization in Research and Education, Leveraging the Emerging Trends in Data Management, accorded this 24th day of September 2021 via Zoom video conferencing live stream on POMI YouTube channel and PySite 21 Facebook page. Signed, Ricky A. Kibinko, MATM, LPT, and Video Virtual Conference Director, and Emijan P. Indonila Palmani, MEd, LPT, National President of PICE 21.
Thank you so much.
Okay, sir. So at this time, I request everyone now to please open your camera for a photo. Again, I request everyone to please open your camera for a moment of picture taking.
Okay, so good afternoon, everyone. So we have two panels in our room. So just keep smiling. Okay, so for the panel one, ready, 1, 2, 3, and smile. Okay, for the next panel, 1, 2, 3, and smile. Okay, so thank you, ma'am. Sirs.
Okay. So that concludes our second day program. And everyone, please, the evaluation link is now open. So once again, good afternoon and see you tomorrow for another talk sponsored by PICE I-21. Thank you, Sir Alberto Dizon.
Thank you po. Bye.
Bye, everyone. Again, the evaluation link is on the chat box. Please have time to evaluate our speakers and also the organization.
Hello sir, close pa po yung evaluation, hindi po ma-access.
Po, sir. Sir, about po sa evaluation, sir, pwede niyo po ma-access po, sir. Kindly tap lang po yung link dito sa my chat box po. And one of our facilitator is now opening it po para po makapag-evaluate na po tayo. Maraming salamat po, sir.
Sir, pag inopen po yun, see your previous response po.
Okay. Po, saglit lang po, ma'am, ha. Tatanungin ko lang po kung okay na po.
Apo, sir. Thank you po.
Okay, at this time po, we're having a internet lag po. Please bear with us lang po, saglit lang po. Thank you so much and have a good day po.
See previous response pa rin po.
Okay po, ma'am. Wait lang po. Okay, ma'am. Can you try na po ulit, ma'am?
Okay, I'll try again, sir.
Okay po.
Okay na po, sir. Thank you po.
Thank you so much, ma'am. And see you po tomorrow.
Yes, sir.
Post po ng evaluation last kaninang umaga.
Opo. Opo, sir. I think, sir, ang evaluation po kanina is still open po.
Nasa email.
Kindly check lang po our emails.
Can we ask sir for a copy of the presentation of our speakers?
Yes, ma'am. It will be sent to you on your email account.
Okay, thank you, sir.
Thank you so much. So yung atin pong presentation po ay ipapadala po sa ating mga emails po. Lahat po pati yung certificates at certificate of attendance or ano pa po yun. Thank you so much. Can we access na po ba, ma'am, sa evaluation link?
Yes po.
Ma'am, sir. Okay, thank you so much po. Sana po marami kayong natutunan ngayong hapon po.
Ay, yes, sir. Opo.
Yes po. Thank you po.
Okay, done na po, sir. Thank you
Thank
po.
you so much, Ma'am Cecilia. Hope to see you tomorrow.
Yes, sir. Leave na po ako, sir. Bye-bye.
Sige po, ma'am. Bye po.
Then also answering the evaluation. So, thank you, sir. And good day.